some more examples of greatest common divisor. So example is find greatest common divisor of 3587 and 1819 and express it in the form 3587 into m plus 1819 into m. Find two distinct pairs of m and n. So first we'll find the greatest common divisor of 3587 and 1819. So the largest number is 3587. So divide this number by the smallest number 1819. So the quotient is 1. Either write in a round bracket 1 or write into 1 plus 1768. So this is the remainder and this is the quotient. So how we can find it? By using calculator, this number 191768, that is divide the larger number 3587 by smaller number 1819 on calculator. Then we have the question 1 point something. 1 point something, that is 1 is the question. And then if you get this number 1, question 1, then 3587 minus 1819 into 1 becomes this number, 1768. This is the division algorithm. And so the repeated use of division algorithm, we will find the greatest common divisor of this number, given two numbers. And this procedure of finding greatest common divisor by using division algorithm, repeated use of division algorithm, is called Euclidean algorithm. So the question is find greatest common divisor of these two numbers, or another question is find greatest common divisor of these two numbers by using Euclidean algorithm. So this is the greatest, this is the procedure to find the greatest common divisor of the given two number by using Euclidean algorithm. So we have to use the Euclidean algorithm, means we have repeated use of division algorithm. So here is the procedure of finding greatest common divisor of given two integer by applying division algorithm successively or repeatedly is known as Euclidean algorithm. So the finding the greatest common divisor using division algorithm, repeated use of division algorithm is called this procedure is called greatest common divisor by using Euclidean algorithm. So first divide the larger number. That larger number is what? 3587 by smaller number. So smaller number is 1819. Then we have the quotient is 1 and the remainder is 1768. Okay. So we use calculator to find these numbers. That is divide 3587 by what? 1819. And then we have the quotient 1 point something. We have the quotient 1 point something. That is 1 is the quotient. And then 3587 minus 1819 into 1 is the remainder, that is 1768. Then next equation is what? Divide this number divisor. This is divisor 1819 by using remainder. Divide the divisor by remainder. So 1819 into 1768. Obviously the quotient is 1, because if you divide 1819 by 1768, then we have the quotient 1 point something. That is 1 is the quotient. And then 1819 minus 1768 into 1, this is the remainder, 51. Then next equation is what? Divide this divisor 1768 by 51, remainder. And then the quotient is 34. How we can find this quotient 34? On the calculator, divide 1768 by 51. Then we have the quotient 34 point something. We have quotient 34, that is by using calculator divide 1768 by 51. Then we have the quotient 34 point something, means 34 is the quotient. And then how we can find this remainder? That is 1768 minus 51 into 34. You use calculator, then we have the answer 34, that is the remainder. So first find quotient and then find remainder. Then 51, divide this 51 by 34. So what is the quotient? 34. If you divide 51 by 34, then quotient is 1 point something, means 1 is the quotient. And then 51 minus 34 into 1 means 51 minus 34 becomes remainder, that is 17. Then divide this divisor 34 by 17. Obviously 2 is the quotient and 0 is the remainder. So we stop if we have the remainder is 0. how long this procedure of applying division algorithm is continued. At the last we have, if we have the remainder is 0, then stop the procedure. Okay, and then second last remainder or last non-zero remainder, okay, that is 17. This is the second last remainder, or this is the last non-zero remainder. Last remainder in every example is 0, and the second last remainder, not image, remainder is what? Is the greatest common divisor of these two numbers, 3587 and 1819. So write in round bracket and then comma. This is the notation to denote the greatest common divisor of 3587 and 1819. All right. Instead of this, write that greatest common divisor of 3587 and 1819 is 17. That is the last non-zero remainder. Is the last non-zero remainder is the greatest common divisor. In every example, last remainder is 0, and then second last non-zero remainder is what? Is the greatest common divisor of the given two numbers. So this is very simple procedure to find the greatest common divisor of the two numbers, given two numbers, and this procedure is called the greatest common divisor using Euclidean algorithm. Then we have to express this 17. This greatest common divisor means 17 in this form: 3587 into m plus 189 into n. That is where to find the m and n, integers m and n. So we from the second last equation, we denote the equations by reverse ordering. Second last equation is denoted by number 1, then third last is 2, and previous is 3, then previous is 4. So numbering these equations in the previous order, second last equation becomes 1, equation number 1, then previous equation is 2, then 3, and then 4. Okay, and then from equation number 1, what we have? 17. Value of 17 is what? 51 minus 34 into 1. This 17 is what? 51 minus 34 into 1. Then if you observe second equation, then what is 34? Is 1768 minus 51 into 34. So here is 34. So substitute here 34 minus sign, therefore write in square bracket. Write in square bracket value of this 34 as 1768 minus 51 into 34 into bracket complete into this 1 as it is, and then multiply by 1 in this bracket. So what do we have? 51. We have the next equation 51 in as it is minus 1768 into 1 minus become plus 51 into 34 into 1 means 51 into 34. So write one more equation here. This equation, that 51 minus 1768 into 1 minus become plus 51 into 34 into 1 means 51 into 34, and then 51 into here is 1, and plus 51 into 34 becomes 51 into 35, because if we take 51 common, then what we have? 1 plus 34 means 35. Okay, minus 1768 into 1 as it is. Then next equation is what? Use third equation. From third equation, find the value of 51. 51 is what? 1819 minus 1768 into 1. So write here 51, value of 51 as 1819 minus 1768 into 1 into 35 as it is, minus 1768 into 1 as it is, using third. Here is use of 2, here is use of 3. So here by using 3, here use 3 equation, and then multiply by 35 in bracket. So what we have? 1819 into 35 minus 1768 into 1 into 35 becomes 1768 into 35 minus 1768 into 1. So if you take minus sign and 1768 common, then we have 35 plus 1 means 36. Okay, and then use the use the equation number 4 and find value of 1768. It is 3587 minus 1819 into 1. So substitute here value of 1768 as 3587 minus 1819 into 1 into 36, as it is here into 36, and then 1819 into 35, and minus minus become here plus 1819 into 1 into 36 means into 36, and then 1819 plus into 35 plus 1819 into 36 becomes 35 plus 36 becomes 71 minus 3587 into 36, this 3587 into 36, and then write it is in the form 3587. So here is 3587 into minus 36 plus 1819 into 71, and therefore m becomes minus 36 and n is what? N is 71. These are the two values of m and n. If we find another, if we have to find another pair, another values of these m and n, then use this formula: d is equal to a m minus kb plus b n plus ka. So what are the d means greatest common divisor. A and b are the given two numbers, that is a is 3587 and b is 1819, and substitute, take k as any number, take k as 1, 2 or any number, and then we have these two values, another two values of m and n, another two values. So uh, just find m and n, one pair is sufficient. Then the next example is what? Find the greatest common divisor of 4999 and 1109. Or another question is show that these two numbers 4999 and 1109 are relatively prime. So when two numbers are relatively prime, if the greatest common divisor of that two number is 1, that is what is the question? Another form of the question is what? Show that the greatest common divisor of 499 and 1107 is 1. Show that these two numbers are relatively prime means show their greatest common divisor is 1, or find the greatest common divisor of that two numbers. So when the two numbers are called relatively prime, two integers a and b are called relatively prime if greatest common divisor of that two number is 1. So here we have to show these two numbers are relatively prime means we have to find the greatest common divisor of these two number, and we have to show the greatest common divisor of these two number is 1. So divide larger number by smaller number, and then what is the question? The 4999 divided by 1109 by using calculator, we have the answer 4 point something. Then 4 is the question. So first we have this question 4. Then 4999 minus 1109 into 4. If we do this calculation on the calculator, then we have the answer 563. That is 4999 minus 1109 into 4. Answer is 563. This is the remainder. So this is the first equation actually. Then next equation is what? Divide this 1109 by using this 563. That is divisor. Divide the divisor by using remainder. Then we have the question is 1, because if we divide 1109 by 563 using calculator, then we have the answer 1 point something, and therefore 1 is the question. And then 1109 minus 563 into 1 becomes 546. Then divide this divisor 563 by remainder 546. Then again the question is 1, and 563 minus 546 into 1 becomes 17. Then divide this 546 by 17 remainder. Divisor is 546. Divide this divisor by remainder. And then question is what? If we divide 546 by 17, then on the calculator the answer is 35 point something, the 32 point something. If we divide this 546 by 17, then answer on the calculator is 32 point something, and then write 32 as a question, and then 546 minus 17 into 32, the answer is 2, that is the remainder. And then divide this 17 by 2, obviously 8 is the question and 1 is the remainder. And then divide this 2 by 1, then 2 is the question and 0 is the remainder. And the last non-zero remainder is 1, and therefore the greatest common divisor of 499 and 1109 is 1. And and therefore these two numbers are relatively prime. Now we have to express this one as 4999 into some integer m plus 1109 into some integer n. Then denote numbering these equations reverse order 1, 2, 3, 4, 5. Then from equation 1, the second last equation becomes 1. Then from this equation 1, what we have, the value of 1 is equal to 17 minus 2 into 8. Then use the equation number 2, then it will use equation number 3, use equation number 4, use equation number 5 successively. So after using used equation number 1, we use equation number 2. So what is the value of 2 from equation number 2? It is 546 minus 17 into 32. So write here value of 2 as 546 minus 17 into 32 into 8, this into 8. Then what do we have? 17 into 1, and this minus minus become plus. Write one more equation here, write one more step here, equal to right, 17 minus 546 into 8 plus minus minus become plus 17 into 32 into 8. So 32 into 8 becomes what? 8 2 the 16 and 8 3 the 24. That is 258. 256. Okay, 17 into 256. And then this 17 into 1 and this plus 17 into 256 becomes 17 into 257. Okay, because if you take 17 as common, then we have 1 plus 256. That is 257 minus 546 into 8. 546 into 8. Okay, then use the equation number 3, that is substitute the value of 17. So where is 17? Here is 17. So substitute as 17 as 563 minus 546 into 1 into 257 as it is, minus 546 into 8 as it is, using 3. Here is the reason, using 3. Then what do we have? 563 into 57 multiplied by 257 in bracket. What do we have? 563 into 257 minus 546 into 1 into 257 means 546 into 257. And here is 546 into 8. So we have, what do we have? If we take 546 as common, then we have in bracket 257 plus 8 becomes 265. Okay, and then substitute the value of 546 from equation number 4. Here is 546. So 546 is what? 1109 minus 563 into 1 into 265. Okay, and then is using 4, and then multiply by this 265 in bracket, minus minus become plus. Write one more step, and then 563 into 257, and here 563 into 265 becomes 257 plus 265 becomes what? Here is the answer. What is the answer? 257 plus 265 becomes 522 minus 1109 into 265. Write one more step, that multiply this 265 in bracket, and then add these two 563 and 563. Okay, into 257 into 265 becomes 257 plus 265, that is 522. Then use the equation number last 5, that is substitute value of 563. It is what? Power of 999 minus 1109 into 4. So substitute here value of 563 as 499 minus 1109 into 4 into 522 minus 1109 into 265. Then multiply this 522 in bracket, and then we have 499 into 522 and minus 1109 into 4 into 522 means 522 into 4, and minus 1109 into 265 becomes this answer 2353. And then write this one as 4999 into 522 plus, here absorb this 9 minus sign, so plus 1109 into minus 2353, and therefore m is what? 522 and n is 2 minus 2353. So these two numbers are relatively prime. So again, the same types of examples. Again, the same types of example. We will see all the remaining examples in the next lecture. Remaining lectures, remaining examples of greatest common divisor in the next lecture.